if you had, I told them, like, if you had me second semester, there was a game, and if you still had them, I would still honor them this semester. So we'll see. All right. All right. Okay. Daniel can sell those on the black market later after class, not in class. Okay. All right. Okay. All right. So the graph of f and its derivative are shown for -1 to 4. So this first function's f. The second one is f prime. A says to find the average rate of change of f over the interval -1 to 4 for how many values of x in the interval -1 to 4 does instantaneous change equal the average rate of change over that interval. So let's take it a piece at a time. We see average rate of change on the interval from -1 to 4. So if I see average rate of change, what am I doing? Average, if it said instantaneous, it'd be line of tangency. Average rate of change is your secant line. So at -1, we're at this point here. Look at f, not the derivative here. And at 4, we're up here. So we've got the point -1, -2, and 4, 1. And we want the slope of that line. So you can do slope formula, or you can count it from the graph if you want. So you've got 1 minus -2 over 4 minus -1, which is going to give you 3/5. It would be okay to just count that from the graph also. So this is we want to let the grader, which is me, know that we know this is average rate of change on -1 to 4. Y's are on top. Correct. So -1, -2 is this point on this endpoint of the graph, and 4, 1's the other endpoint. We just did the slope. And it would be perfectly fine if you didn't do the slope formula at all, and you just counted up 1, 2, 3 over 1, 2, 3, 4, 5. Maybe just count it from the graph. Slope formula is y2 minus y1 over x2 minus x1.
Oh, there's a repeating one.
Yeah, you got those double negatives become positives.
I thought we were just like literally like doing the x and y together.
Okay? So, if you see average rate of change, you're looking at slope through the endpoints of whatever interval you're looking at. Okay? So this is our average rate of change. Then they ask us for how many values of x in the interval -1 to 4 does the instantaneous rate of f equal the average rate of change over that interval. So what is average rate of change I found is 3/5, right? What is the instantaneous rate of change? Slope at a given point, which is also our derivative or line of tangency. All of those things are good. So you got a couple ways that you can think about it. You know what? I think my key's wrong on this. I think I messed this up. No, it's fine. Okay, so there's 2 ways you can think about this. It's fine. It's not messed up. So the first way I was thinking about this is just thinking, where do I have a parallel tangent line, which really might be, I drew it in right there, but I don't know, that doesn't look perfect right there, but something like that. But there's an even better way that you can know, because they gave you the graph of f prime, right? So on the graph of f prime, right here is 1, 3/5 would be about right here. So right here, f prime equals 3/5, and right here, f prime equals 3/5. So f prime, we would know, 3/5 we would know that would be, like we put in a line right here, we're still on A. So we can look at this graph and see the derivative has a y value of 3/5 at least, or at those 2 points. So you can know for sure, like more. Yes. Because on this graph, this is your derivative. So, like if I want to know the derivative at a certain point, I just look at the y value on that second graph. Yes.
Yeah. But it'll be on the y.
Yeah. So like, yeah, on your y coordinate of this. So on this graph, like if I wanted to know f prime of, we're going to need this in a second, f prime of 1, the derivative of 1. So I could look at the graph at 1 and try to figure out what that slope is, which may or may not be that easy to do. Or I could just go to 1 right here. The y coordinate that goes with it is -2. Right. Well, no, you're looking at, we want to know f prime, what we're trying to find is where f prime of x equals 3/5. Right? So f prime of x is this graph, and we want to know where it's going to equal 3/5. 3/5 being the y value on this graph. So 3/5 would fall, yeah, on this graph, because this is f prime. On this graph gives us the value of the function. This gives us f of x. So we would say the average rate of change equals the instantaneous rate of change, yes, twice on the interval from -1 to 4. Yeah, for this problem, it does not ask what those values are. So you just have to tell how many times. There's not any way that we could know for sure. We could estimate them, but we wouldn't be able to know for sure. And they didn't give us the equation of this graph. So even if we did have a calculator, we'd just be guessing at it because we don't have the equation. If we had the equation, we could figure it out, but we could say f prime of x equals 3/5, and we could solve it if we had the calculator and they gave us the equation, but we don't have one here.
So you're not writing like f of x, like the average rate of change of f of x equals, or like.
It would be a good idea to put of f there, but because basically you're restating what's said here, but I think you'd be okay if you did not. Yeah, like if you said the average rate of change of f equals the instantaneous rate of change of f twice on -1 to 4, that'd be better probably than what I've written, but what's here is acceptable. It's good enough. Yeah. Okay. Questions on A? Alright. For B, this asks for the equation of the tangent line, or line tangent. There are, you cannot just write it. you don't have to write much more. But there are 3 things you need to tell me for a tangent line. You need to tell me the point, the slope, and the equation. So if you are looking for the equation of a tangent line, you need the point, the slope, and the equation. How do we find the point? We need f of whatever point we're looking at, which in this case is 1. So if I'm looking for f of 1, I'm going to the graph of f, not f prime, but of f. And I'm finding the y coordinate, which is 2. So all you have to write down is f of 1 equals 2, but you need to write that down. Yeah, you need to write that down. Okay. Then for the slope, what do we need to know? You still gonna have to estimate a little bit. The slope is the derivative at 1. So if we want f prime of 1, we're not looking at the first graph, although you could estimate the slope, but you might be off if you do that. We're looking at the second graph, and we get -2. So we've got the point 1, 2. We've got a slope of -2. And so from here, you can just write the equation. So y equals -2 times x minus 1 plus 2. And just leave it like that.
Jack, can you say my name back there?
Let's see, I put it on the key. I think it's 2. That's 3. A point. Yeah, I know. I mean, I don't have, well, these questions, for some reason on the progress check, they did them out of 7 points, which I don't like, so I had to add 2 extra points in somewhere, and I think that f of 1 is like an extra point that I gave you. So, probably like maybe.
So if we write like the slope equals -2, that would be wrong.
I would do f prime of 1. That's going to be more specific. Okay, now let's look at C, because C is where you're going to run into needing to know something about limit definition of a derivative. There's not going to be a lot of limit definition of a derivative on the test. In fact, I don't believe there's anything where you have to do limit, like you have to, free response, give me limit definition of a derivative.
I don't know much about limit definition of derivative.
Okay, so,
I don't know much about limit definition.
alright, so, for C, they ask you to find the limit as x approaches 2 of f of x minus f of 2 over x minus 2, and the limit as x approaches 3 of f of x minus f of 3 over x minus 3, or give the reason why it doesn't exist. Okay, look, this is simple. This is simple, and you don't have to do a lot of work for it. And this is what it's going to look like on your test, okay? So, limit definition of a derivative. There are 2 types of limit definition of a derivative that we learned, okay? So, I'm going to write those down over here. So, the first one that we learned was to find, well, let me write right there, was to learn the derivative at a point. So here a is a number, like at 3 or at 2 or at 7 or something like that. And it is limit as x approaches a of f of x minus f of a all over x minus a. Second part, I think it was like the second piece of like 2.2. Okay? We also learned another limit definition of a derivative. It was to find, and the one with the h is the one where we usually got an x still left in our answer, right? And it was the limit as h approaches 0 of f of x plus h minus f of x all over h. So when you see limits in f of x's, you should be thinking this is probably a limit definition of a derivative. So looking at what we've got here for these two pieces, which one does it look like they're using? The first one or the second one? They're using this top one. And what number have they plugged in for their a? 2. So, and 3 for the second one. So let's start with the first one. The limit as x approaches 2 of f of x minus f of 2 over x minus 2 equals the derivative of f at 2. It equals f prime of 2. You have to recognize this is the case.
So legit is translating.
Right, just translating. Now, f prime of 2, I can find because I have a graph. What is f prime of 2? It's 1. Because this is the derivative. Now, if it were asking for the derivative of this graph, then it would not exist because you got that sharp turn right there. See the sharp turn right here? So, if I asked for the derivative of derivative, but it's not. So, we're just given the y coordinate, and so it is 1. You could also look at f, and right there at 2, kind of estimate, but that's not your best way to do it, right? Okay? What about the limit as x approaches 3 of f of x minus f of 3 over x minus 3? It is f prime of 3. You need to write down that you know that this equals the derivative at 3. Because it is just limit definition of a derivative. So you are seeing it and recognizing that's limit definition of derivative and recognizing they plugged in 3. So it's f prime of 3. If you see a limit with f of x's in it, it's probably limit definition of a derivative. So if I look up here at 3, I got nothing. Both of these are open circles. If I look over here at the graph of f, what do I see right here? Over here, let me erase this. Let me erase all my nonsense there. At 3, I have a sharp turn or a cusp on the graph. So we can say does not exist. And you have to tell why it does not exist. So it does not exist because f of x has a cusp, or if you don't like that word, you can put sharp turn. That's a U. It's plural cuspes. At x equals 3. I guess in this particular case, you could also say that f prime of x is undefined at x equals 3 because they do give you that graph and you got both open circles, which means that would be undefined. So that would also be acceptable at that point. You need to write this down because this isn't actually work. It's just showing the grader that you recognize that this limit equals the derivative at that point. So it's not like actually work that you're doing, but you're showing the grader that you know what that is, and then you're going to look at the graph for it. It's asking for each separate, so the first one exists and it equals 1. You don't have to give like a reason if you find the value. But for the second one, it does not exist because there is a cusp there. Okay, questions? All right. not going to ask what was happening back there. Alright. Okay. Yeah. No necesito entender. Alright. So, what you just said about me then. Yeah. So that I could have lots of good quotes from Daniel. Yeah, leverage is, yeah, that's important. You might need to, if you don't get that Moorhead, you're going to have to apply for some different scholarships. And you might need me to write you another recommendation. So, and Moorhead's hard to get. Hopefully you'll get it, but it's really hard to get. I've only ever had one kid ever get it. Madison Shoemaker. I've had a few make it to like interview rounds, but okay. All right. D, derivative. What have we got to use? Product rule. You must use a product rule here. So, anytime it wants a derivative, so you have, anytime you have two things multiplied and both pieces have x's in them, you have to use the product rule. So you can't just take the derivative of e to the x and take the derivative of f of x. You've got to do e to the x times the derivative of f of x, which is f prime of x, plus f of x times the derivative of e to the x, which is e to the x. So you need to write that down. You're going to get a point for that. Yeah. Product rule, your first piece is e to the x. The second piece is the f of x. Ooh, those look like the same color. Okay. Then we plug in 0. G prime of 0 is going to be, all the x's get replaced with 0. So e to the 0 times f prime of 0 plus f of 0 times e to the 0.
So why would writing that not work for both? Like g prime 0 not work for g prime 0?
You might be okay, but in this particular case, you get a point for g prime of x. So I would write it with the x just to be sure. Yeah. Alright. So what is e to the 0? 1. F prime of 0. I'm going to find that from up here. What is it? 1. I'm getting that from that graph. F of 0 is going to be 3. And e to the 0 is 1, so you get 1 plus 3, which is 4. Okay, questions?
Literally, Matt, this was the important part.
Okay, real quick, let's just look at B. Write P prime of 4.5 as the limit of a different quotient, and then ask you to approximate this. Limit of a difference quotient is limit definition of a derivative. So, for this, you got two ways that you can do it, but the easiest way is to use that f prime of a formula that I had before. Yeah, limit definition. So if it says limit of a difference quotient is the slope. So when you see difference quotient, think slope. And limit of a difference quotient is going to be like that slope formula with the limit as x approaches a. So x approaches 4.5 of, you would just do f of x minus f of 4. Actually, I should not be using f. What should I use instead? P. I think you're probably going to be okay as long as they have not used f somewhere else in the problem, like as a different function where it looks like you're using the wrong function. So P of X minus P of 4.5 over X minus 4.5.
Do you want us to use like the letters they use, or can we just always use that?
I would use the letter they use. And really, I've still messed it up. What have I done wrong? All those X's really should be T's. Now, that's something I think, in general.
That's the sickest problem with variables I've ever seen.
Yeah, I know.
T's and P's.
When I was at a training one time where somebody asked about this, and they said, in general, if you use X's when you should be using T's, they're not going to count off unless there's also another part of the problem where there's X's and then there's also T's, and it looks like you used the wrong part of it. So like here, they don't use X's anywhere. So if you just use X's for everything instead of T's, you would probably be okay. I'm probably going to have mercy on you. I can't say for sure. Like if you use an X and a T both in the same expression, they might count off on the AP exam. I'm probably going to not count off unless there's an X somewhere else in the problem. Okay, and so this, let me make sure. Here, this is your difference quotient. So you're done with that part. You've shown your difference quotient. I wrote on the key, I did P prime of 4.5 equals. But I think you would be okay without even writing that. So this is your difference quotient. This would give you the exact value if you found it. They ask you, though, to estimate. And the only way you're going to be able to estimate is using that table because you don't have an equation for anything here. So you're just going to pick the points closest, which are 3, 204, and 6, 600. Yeah, so I'm just pulling the two closest points to 4.5, and you're just going to do the slope formula. So 600 minus 204 over 6 minus 3, which is going to give you 396 over 3. And if you divide, I believe you get 99 there. Maybe. Hold on. I think I just was pulling that out of my head. 132, sorry. Don't do it. I was pulling it out of my head. I think it's another question I'm thinking of that was 99. I'll tell you on this one, you can leave it 396 over 3 if you want. Technically, you can leave it 600 minus 204 over 6 minus 3 if you want. Because it asks for you to write it as the limit of a difference quotient. So that's what it's wanting whenever. Yeah. It doesn't ask you to find it. Yeah. I know.
Wait, so like it's just straight up asking you to write that even though it has nothing to do with
Yeah. And so this is 132 bit. Yes. That is intermediate value theorem. So you plug in 3, you plug in 500, which you have from the table. So P of 3 is 204. P of 6 is 600. So if it goes from 204 to 600, it's got to pass 500 as long as it's continuous. I should say this. On this one, part C is intermediate value theorem. Intermediate value theorem only applies if this is continuous. Does it tell you anywhere it's continuous? Unfortunately, we cannot use that sort of logic on the exam. So, but what did Addison just tell us? It was very useful.
Okay.
Wow. All right. Alright, so differentiable function. What do we know about anything that's differentiable? It has to be continuous. So like you would say, since
Is that what you just said?
it is. Since P of T is differentiable, it was very useful. It must be continuous. And so then you would do the rest of the stuff for intermediate value theorem. But that's how you tell that it's continuous. But I'm going to quit now. Yeah, this will be an intermediate value theorem problem. No, I'm not done. I'm just quitting. I give up.
Do we have to say, like, because...
It could be. It's not one of the main things I'm testing, but anything is fair game to be thrown in that we've done. So like part C is not, it's from unit 1, intermediate value theorem's from unit 1, but it could get thrown in. Yes.
So before it works right because of the intermediate value theorem?
Well, or then you can say by intermediate value theorem, spell it out, yeah, somewhere it's got to be mentioned in
So it does have to be said
somewhere you got to say intermediate value theorem. Intermediate value theorem only applies if it's continuous. Right, it tells us it's differentiable, and anything that's differentiable also has to be continuous.
If we forgot that differentiable meant continuous, which we got, it would be f, we'd have to prove that the limit exists, f, the number exists, and
Yeah, you have to prove continuity, which you can't do because you only have a table.
so yeah, you just got
So you have to know this. Yeah.
Intermediate value theorem says
So much.
204 equals P3 is less than 500 is less than P6 and F600 is less than some value at which such that T equals 500 on the interval.
Can you say that again? It's on the answer key, yeah. It's on the answer key. I think I am, but it quit